Good afternoon, good evening, whatever time it is, wherever you are. My name is Noel Power. I work for SUSE and I work on Samba, and I'm also a member of the Samba team. My talk today is about the Windows Search Protocol and trying to get it to work with Elasticsearch. So what I propose to do is to briefly recap about the experimental Windows Search Protocol work that I've been doing for those who haven't been at one of these talks before. So I'll just talk really briefly at a high level about Windows Search Protocol itself, what it is, the service that is, and what is part of what's provided by the experimental work that I have. Then I'm going to talk about Elasticsearch and what I've done to sort of look into it and why and what I found out, and how it works, etc., etc. Then I hope we'll have a chance to just do a quick demo, and then there'll be questions if anybody has any. So I'll try to get through this as quickly and as less awkwardly as possible. I don't know whether doing a talk this way is more or less intimidating than doing it live, but we'll see how we get on. Okay, so we'll just try and briefly recap about the Windows Search Protocol work that I was looking at. So firstly, a bit of history. When I first started working on Samba, it sort of coincided around the same time that there was a Hack Week project here in SUSE, so I just picked something to work on, basically in order to dip my foot in the Samba code and try to understand some stuff about the protocol and the internals of Samba, etc. So you can take it that this project is basically a kind of a personal project, a hobby or whatever. The Windows Search itself, what is it? Okay, so on Windows or in a Windows server, you can basically point the Windows Search service at either a share or a number of directories, and it will index those for you. So basically what that means is that the search service will scrape through your file system, pulling out metadata from the files and shove that into a database somewhere. And the idea is that you can do very quick searches later over the network. So Windows users will be familiar, for example, this window here, which is this Windows Explorer search ribbon on the Explorer window. And you can see generally what you can do is pick some type of object like a movie or a picture or maybe a document, and there are handy little drop downs to further refine that search. And there's also a window there where if you had the ability to know the magic secret sauce, you could type a query in there. So my focus is basically trying to satisfy the queries that this window provides in order to have some sort of functioning Windows search service working over the network, talking to a Samba server. So but just quickly about the protocol. The protocol, its whole reason to be alive is just to shove queries over the wire and pull results. It is focused though on full text queries. It sits on top of SMB, or in particular the SMB pipe protocol, so there's a dedicated pipe for this service. And the interesting thing, at least in terms of implementing the Windows Search server, is the query request, which contains all the information that you need to perform some sort of a search. So a bit more detail about the protocol itself. It's mostly simple request response. The messages it's not RPC or anything like that. They're sort of heavy binary messages that have been converted or marshaled from heavily nested structures. In terms of sequence, it's quite simple. There's a connection request goes out, then a query, and then a number of status requests looking to know is the query complete, how many results there are, and then there are messages about pulling results. There's also a feature where if some of the columns that you get back in your results are too big, they can be deferred to later. And we might talk a little bit about that because it's something we don't actually support at the moment. So I'm just going to give, again, a quick overview of what's available there in the work itself, or the work in progress server that I'm looking at. This isn't upstream, so that's something that I have to say. So this isn't part of Samba officially yet. And it consists of a number of parts. So there's the server, there's a CLI client called WSP Search, and there's a sort of developer-centric tool called WSP Sparkle, which allows you to pull the query bytes from the query message and basically run the conversion on it and get it to spit out the converted routine or the converted query, so you can look at it or push it manually into, say, Tracker itself. So in saying that, the server itself, it kind of looks like this. You got a client request in, it talks to the SMP daemon. Once it recognizes that it's the Windows search service that it's talking to, it spawns a single child process. So there's a single WSP server for all client requests. And the intention is that you can have multiple backends. So with that in mind, I have an abstract interface. There is only at the moment one concrete sort of implementation of that, which is Tracker, and sort of a pseudo one there for elasticsearch, which is the purpose or the subject of this talk. Just more detail about the implementation. It's obviously it supports GNOME Tracker. It uses glib integration, so we're talking directly using native glib APIs, and it supports the basic queries that you saw in the Windows UI earlier. So just a little bit about the query and the query conversion that goes on. A Windows Search Protocol query consists of a number of bits of data or information. So there's information about the columns that you want to retrieve. There's information about sorting and grouping. But the real sort of meat consists of a command tree of restrictions which are used to include or exclude results from the search. So Windows Search Protocol itself defines many restriction types. They can be divided into sort of two categories: simple, which are kind of based on property values. So you're maybe looking at something that matches a particular property, or maybe a range. So looking at something that has a date that's before this or after this date, or maybe something to do with size or something like that. But there are other more, I'd call them exotic restriction types that are to do with the full or the full text specific sort of kind of stuff, like weighted or operations or probabilistic ranking and stuff like that. Luckily, the Windows Search UI produces queries of the more simple variety, so we haven't really had to deal with these more exotic types. So what we got to do, we've got to convert that ugly binary beast into something that Tracker can understand. So what I do is I start with a template. You can see here on the second line or third line, where we have a number of bits that we expand out. So the columns, the sort, and the restrictions are all exploded from information that we can get from the query message. And the restrictions actually directly are related to those restrictions that we get, that we mentioned, that are part of the binary command tree. So the CLI client that we have operates in two modes: simple and complex. So the simple one looks a bit like this. So you just pass it a kind, which is one of those items that was in the drop-down menu from the Windows Search UI. We can look a bit, hopefully, a little bit more at this when we get to the demo stage, so I'm going to just really skip through this. There's another variant where we pass a query, as in a more complex query. You can give it a bit more detail. And the third one is the translator tool. So this is useful where you're capturing traffic on the wire, and you either don't have the server available, or you're looking at pure Windows traffic and you want to see, well, what does my current server make of this in terms of query translation. So you can see that the create query message is selected. Then you can select on the middle pane there, you can select the Windows Search Protocol part. And then with the context menu, you can just export the bytes, and you can feed that into this WSP, the Sparkle tool, and it will spit out the Tracker Sparkle query that it'll convert to. You can then run that, for example, using the Tracker command line tool. So there's a Tracker CLI tool where you can pass this Sparkle to it and run it locally. So getting on to Elasticsearch. So this whole thing came into my mind because recently Spotlight got support for Elasticsearch, and I participated in some of the reviewing of that, so it came to my attention. Also, I guess I've been a bit guilty because I haven't really looked too much at Windows Search Protocol in the recent past. I've really done nothing with it except try and keep it running. A bit of making it work on master. That's been sort of what I've been doing mostly. So there's also been a little bit of interest on some of the lists, and some people have contacted me personally about the state of the Windows Search Protocol sort of features. So yeah, it was another hack week at SUSE, so I decided to have a look at Elasticsearch in order to refamiliarize myself with the whole thing again. So Elasticsearch, what is it? So basically, it's a search engine based on the Lucene library. It's cloud capable, you can cluster it. It's fast, it uses JSON and HTTP, but more importantly, it's the most popular enterprise search engine out there. So it makes it interesting to look at, because scalability is definitely something that is relevant when you deal with Tracker. So there's probably a different focus for Elasticsearch if you were to use it than maybe using Tracker as a backend. And it's also got a very rich API, RESTful API. So what did I do in terms of looking into Elasticsearch? So obviously the first thing I did was poke around with the Spotlight code. Unfortunately, I don't have any Apple toys, so I couldn't run any of this except the test code and look at the test or look at the code itself. Additionally, I just looked at the Elasticsearch website, and I've put some handy links here, links at least that I found were interesting and handy. So there's the intro. Obviously, if you want to try and convert queries, you need to know about the query language. So there's a link there for that. And then the RPM. So it's actually one of my comments about Elasticsearch is that it was very easy to install, to get working, and to look at. However, one of the things about it is the documentation is very generic. So there's lots of fake examples where you populate data into the index and then query it. That's not very useful, obviously, for the purpose of trying to search file systems. But luckily, there's this thing called FS Crawler, and again, some links here, which basically will crawl through your file system, point it at some part of your file system or some parts of your file system. It'll crawl it, it'll suck the metadata out of it, and it'll push all of that into Elasticsearch for you. So it basically does everything that you really want. Another thing about Elasticsearch, and say the same about Tracker, is that it's actually easy to test queries if once you have the query expression. So with Elasticsearch, you can just use curl. So as I said, this was part of a hack week, so I wanted to get things working fast. So the first thing I did was to start looking at the WSP, the Sparkle tool, and I changed that so I could pass a query to it, so I could start working on the query conversion independently, and then looking at those queries, start manually putting them into curl and trying to get it to work. So obviously WSP to Sparkle isn't a very generic name, so I also changed the name, also made it take a new parameter so to reflect that you could be looking at converting queries to different flavors of backends. So again, hopefully we can have a look at this in the demo section, but you can see we're just passing WSP to Elastic, passing in a query, and you're getting out a result. I'm not going to go into any of the details of either Tracker queries or Elasticsearch queries in terms of the format of the query and stuff like that. If you're really interested in that, there's lots of documentation available, and you can bore yourself to death with that if you like. I've retained the functionality where you can just point it at query bytes, and again, there's another example there. But the query that comes out of this guy is only what we partially use. So there's actually a bigger template, which I shamelessly stole from the Spotlight code. And again, similar to the Tracker approach, start with a query. There are a number of elements that we blow up from information that's in the query message. So the obvious one is columns. And then the restrictions part, which again is the binary command tree. We also have this from inside, These are interesting. They're actually to do with actually how you pull results back. So from is where in the results set you want to start from in size, how many results you want to get back. So the initial query that you do, they'll be 0 and 0. And then when you actually come to go and get results and page through them, we use these other values. This actually is a great match for the Windows Search Protocol. We'll talk a little bit about that again later. So what else did I do? I took the cheap and nasty approach. I took the concrete implementation of the abstract interface for Tracker, and I just copied all of the code and then just started hacking away at it, pulling out the Tracker specific stuff and using the HTTP library that's in Samba, and again, shamelessly stealing similar code from the Spotlight implementation. And I actually got some simple queries to work, which is what I hope I get to be able to show a little bit later. So what were my overall impressions about Elasticsearch? I was really impressed with how simple it was, especially compared to Tracker, in terms of integration and communication. The API also seems much richer for the full text search, particularly full text search relevant bits of it. Processing the results seemed a little bit slower than Tracker, and I suppose that's to do with we're both pushing textual data across the wire and then pulling it and parsing it afterwards. I did have some issues with HTTP pipelining. The model that I was using was similar to how the Tracker version works, where I just have one connection to Tracker, and then all of the client connections talk to that one Tracker connection. I was doing a similar thing with Elasticsearch, but I was getting out of order messages. So the protocol, I think I mentioned it earlier, the first message is a connect message in the client conversation, so you can quite easily set it up that you get a dedicated HTTP connection per client conversation, and then these problems go away. I suppose not surprisingly, when you copy all of the code, you get a lot of duplication, but I think the exercise was still useful in terms of identifying portions of the code that may need to be split out, or that could be particularly useful between different index or implementations. So with that in mind, that's the rework that's really needed, is to reorganize things to avoid the code duplication that's there, maybe provide some sort of reusable API that other index or implementations may be able to use, but certainly to be shared between these two. Another thing that cropped up that I guess I wouldn't have been aware of, only that I started actually getting things to work, getting a real searches to work, is that Elasticsearch, I suppose for reasons of scalability and stuff, it's not unusual for different types of data to be stored in different indices. So maybe you store your documents in one index, your videos in another, pictures in another, that kind of thing. However, from the Windows Search Protocol point of view, the query sort of expects that you can disambiguate types of documents with a property, for example. So this has implications for how the query could be set up. I mean, it can obviously can be done, but it would be a bit more complicated. And folder actually is one of the types that you can search on in Windows Search. So these are things to think about. Another issue with Elasticsearch is that it's schema free, so it's up to whatever's pushing the data into the index to decide what is actually stored in it or what properties are stored in it. So that means, of course, that you need to have some sort of dynamic way to map between the Windows Search protocols and properties and equivalent properties that are stored in Elasticsearch. But it's more than that, because it's never just the property. There's stuff that needs to be done in terms of creating the query depending on the property that you're dealing with. There's also the columns that you get back need their data to be converted in some way that it's in a suitable format for the Windows Search Protocol. One thing that would come into mind, for example, would be paths. So paths in Windows Search Protocol are normally the file schema, so file : // then the NetBIOS name, then the share name, and then the rest of the path. Whereas obviously in Tracker, for example, or Elasticsearch, you're going to get a system, either a system path or a system file URL. Now there are other examples to do with things like there is a thing called, I think it's called item name text or something like that. There are so many similarly named properties, I can't recall the details, where given a particular file, say something like a JPEG, it will give a textual description of that. So it could be something like bitmap image or something like that is what will get returned. So you're having to do some conversion based on the extension in that case. So there's all sorts of issues like that in terms of how do you make that, shall we say, pluggable or configurable, because yeah, something we'll have to think about at some stage probably. So like, what is the skinny, as they say, Elasticsearch? How does it stack up? Does it really help? So these are the kind of the common problems with the implementation, or common or problem areas. So mapping of restriction types would be one. Does this help? I think it definitely does. Just looking in the documentation, I can see lots of text bits that are describing the sort of full text specific querying behaviors that match some of these more exotic restriction types that I don't see in Tracker. They could possibly exist in Tracker, but I don't see them. Mapping between properties, I don't see any difference there. They're exactly the same issues. Cursor navigation, that is page entry results, huge improvement, especially in terms of scalability. The API matches pretty much exactly what you want. Nested queries, these are queries based on previous queries that are open, where you refine the results of those queries by specifying yet more restrictions. I don't think it makes any difference because neither Tracker nor Elasticsearch seem to support anything like that anyway. Another thing is entry ID mapping. So this is something to do with these deferred values that I mentioned earlier. So, and additionally, when you click on search results, there would be a secondary search would happen, maybe looking for more specific data, like say, for example, you click on a document in a search, it would probably use the entry ID, which is a unique ID that identifies the document. It would use that in the query. So it would query for the document with this specific ID and maybe try and pull the keywords from the index or something like that. So in the Windows Search Protocol, the entry ID is a 32-bit integer, but in Elasticsearch and in Tracker, these are text IDs or byte IDs, I guess. So in Tracker, to URL in Elasticsearch, it's an up to 512 byte ID. Usually it's a small string though, or something that is represented as a string. So it basically means that you need to have forward and reverse mappings between this entry ID and this string ID. But it's more than that because of the limitation of the size and the fact that you have this single client or single server serving all the clients. You have to deal with the issue of having to recycle entry IDs. So the entry IDs that are there would be relevant for every open query that has results in order to have a unique ID for every document that a particular client may request at any one time. So this is why I've avoided it. The other issue with it is that with the query string method or template that I'm using at the moment, in Elasticsearch, you can't use it in combination with this underscore ID, which is the document ID, or at least I didn't find a way yet to do it. Whereas in Tracker, you can actually do it quite naturally. You can treat it like an ordinary property. And there are a number of other IDs, chapters and bookmarks. We don't really support them at the moment, so I'm not sure if this will help or hinder. Similarly with grouping of results and aggregations, and I mentioned scalability earlier. This is definitely going to help in that instance. So on to demo. So hopefully I won't crash anything and the demo demons won't bite me. So I'm going to share my whole desktop this time. And hopefully we can see some of the things that I was talking about in action. So, for example, the simple search I mentioned earlier, I'm going to run that, but first, it's probably good to have a look at what Wireshark is doing. So we can have a quick look at the capture of that. So I'm just capturing two interfaces here, the look back to capture the local Elasticsearch and the local SMB daemon. And we'll have a quick look in a minute as well on a Windows search client. Or sorry, not a Windows search client. Yeah, a Windows 10 client. So we're going to filter on, as you can see up here, the search protocol, HTTP, and SMB2. So that should basically get us everything. And this is just a simple search for documents that mention Berry. And we get 4 results here. And if we look quickly at Wireshark and look at the Windows Search Protocol specific parts, we see our create query. And we look here and we can see the actual template expanded out that we were looking at earlier. So you notice that we've got a value 0, size 0. We're only looking for one column. And here we have a truncated query. So here's maybe why it might, or a useful use of the WSP2 functionality. So you can select that, export bytes, save this. Here's one I prepared earlier, but we'll override it. Please don't crash. Okay, so here we have the full query that we probably weren't getting all the details of in Wireshark. Again, going back to Wireshark, if we look at it getting the results, you can see there's a get rows request here. It's looking to transfer 4 rows. And this special bookmark here just means start at the start. So we should see following that the corresponding Elasticsearch query query. So we're starting from 0, trying to get 4 items. Again, file URL and the same query. We get back this JSON results. You can see the URLs of the files that we're getting back, or the hits. And then this is bundled up in a format that WSP can understand. So here's what I was talking about with the with URLs, for example. So you can see you got the NetBIOS name here and the share, whereas if we looked at the results back here, you'll see it's a proper file system URL. So let's just quickly restart that and maybe do a different kind of query. So have a complex query here where we're selecting a number of different columns, and we're looking at music and looking at a particular album title. And we get back a number of results again. And here, looking at Wireshark, we can see again our query message here. This time, you can see there's a number of different columns, and then we're getting rows back again like we did previously. So let's just have a quick look at Windows 10. Bear with me while I probably put in the wrong password. Okay, so what we have set up here are the two shares. They're both exporting the same directory. One has WSP enabled and the other one doesn't. So you can see that here. So here we have test share when we've got WSP enabled and the other one doesn't. And go back to Windows. And we can run, say for example, let's look for pictures. So we're getting back like 4,000 pictures. We can maybe tweak them, the results based on size. If we look at the unindexed one, for example, for comparison purposes, look at the same search picture. Gets it back actually quite quickly. If we're looking at size, again, it's quite quick. But all searches are not the same. So if we look at the music one that we did previously from Windows as opposed to from the Linux client, firstly, I just want to reset Wireshark again. So let me just delete this query here first. And this guy has started to spit out more messages. Okay, so let's try this same search again. See, we get it back nice and quickly. And if we just look at kind of the Windows search specific traffic that we have, you can see that even for that simple query, there is quite a lot of Windows search protocol stuff going on. Typically, when you do a search from the UI, there's a number of parallel searches happen. Not sure exactly why. I guess Windows is looking for more data associated with the results, which is why one of the reasons why I started looking at a Linux-only client, because it allowed me to make more refined searches that I had more control over in order to try and increase the coverage, for example. So if we just go back to the original filter that we had, we enabled that and restart it again. And if we run the same search on the non-indexed one, see, we'll get a different result. So this is good to show the advantage of having something like the Windows Search Protocol involved. If we look at what's going on here, you will see that first of all, it's doing a lot of finding recursively of all of the files in that share. Later, it's going to try and open them to see if they exist or not. And then quite soon down here, you're going to see that it's actually opening the file and pulling out, reading a number of bytes in order that it can read some of the MP3 metadata in order to figure out what the album name is. So this hopefully will eventually finish. And when it does, I'll open up for questions. Hopefully it will finish. One interesting thing though about using two different types of indexers are the results can be quite different. So for example, you can look for documents here. Oops, that's looking for documents and music all at the same time, which is not very clever. Now we can look for documents. Oh, still. Why? I just want to look for documents. Here we go. Right, so I've got 67 items there. And this one eventually returned. So if we look back here, yeah, well, we're getting the other intermingled search here, so I think you get the idea anyway. It had to do a lot over the network. But if we just quickly look at documents here, see that we only get 34. So obviously this one is marking different things as documents. For sure, the open document stuff, so ODPs and such, but there must be other bits and pieces that it's doing. You get similar differences with the music and pictures, believe it or not. So music, obviously, the native Windows search is not going to pick up OGG files, for example. So I'm going to re-share back my presentation. And if there are any questions, I'll take those. And there's a question from Ralph C asking about configurable attribute mapping via JSON file, because that's what Spotlight does. And yes, I'm doing something similar, but as I mentioned, it's not just the attribute mapping is the issue. There's more that needs to be done in terms of configuration. So it's not just the attribute needs to be mapped, it's also the conversion routines need to be mapped, or at least be somehow configurable. And additionally, even how there are common tasks that need to be done in terms of dealing with the restrictions. So for example, there's a restriction that deals with scope, scoping what directory you want to search under. So Windows Search Protocol isn't targeted at a particular share, it's targeted at the server. So you're using information in the query in order to determine what share you're dealing with, because ultimately you would like to maybe have a share configured as WSP, but maybe WSP with tracker, and another share WSP with elasticsearch, for example. So yeah, hopefully that answers that question. Any more questions? Actually, I didn't come to any conclusions. So I could take a question again in a second. So just to wrap this up and give some handy links, I think Elasticsearch is really promising. I think it's really worth investing some effort into trying providing the code for an Elasticsearch backend. If somebody could help, it would be great, because both Tracker and Elasticsearch, really, you can work on the query translation without having to do anything else, as I demonstrated with the WSP2 tool. And the code, if you want to see it, there's a number of branches now in my Samba Git repo. So the first one is just normal Tracker WSP ported to the latest master. It's works as badly as it ever did. There hasn't been anything new done in that. The next branch has the beginnings of the Elasticsearch stuff in it. It doesn't have any of the server-side parts that I just showed. It just has the Elasticsearch query conversion. And the last one, as the name suggests, is the extremely hacky code to provide the demo that I showed here. So I'll just quickly, you can see if there's any more questions. There's one question: are the search results filtered by ACLs? In Tracker, they are. In Elasticsearch, I don't even do the sorting, so no, it's not. And probably, I'm not sure how to handle the ACL element in Elasticsearch, in that I could do the same as what is done in Tracker, which is that I try and open each result to determine whether it should be included in the results or not. So I switch to the user and try and open it as the user, and then discard it if I can't. There's probably a better way to do that. But yeah, we need to consider ACL filtering, because you don't want, for example, to be able to grab the keywords out of your boss's salary document. Well, you actually probably do, but he probably doesn't want you to do that if you don't have the ACLs to do it, but the indexer does. Maybe drop the tracker back. This is from Ralph. Maybe drop the tracker back and to speed up integration. Yeah, maybe. I'm not in love with Tracker because Sparkle just does my head in. So uh, I think about it.